sure you want me to do this?
Yes.
Okay, is that better? Okay. What we actually have is x squared, that's still annoying, plus 0x minus 4. Okay, so that's why that last term is negative and why our signs are different. Okay, Danny.
On the assignment, is it always going to be like that? Just two variables, I guess, two terms? And
Most of the time,
those square out?
if it works out that they are perfect squares and then you can take a difference of them, then yes.
Yeah.
Okay. So here, is this a difference between two terms? Camden?
Back on the last one, will we write down x squared minus 4 or x squared plus 0x minus 4?
When you rearrange it, just write the x squared minus 4. I was just showing you why we get a plus minus here on those two. But you do not have to go through that whole process. Do you have a question on this one?
Yes.
Mm-hmm.
What would our answer be then if it's just the x squared minus 4, but then would we be able to stick with it? Okay, so it's just that.
Yeah,
So
I was just going through and showing you where things came from and why. So let's get to the simplification of it. So looking at this, do we have a difference of two perfect squares? Can we take the square root of 49m squared evenly? Can we take square root of a squared evenly? Do we have a difference between them? So then we can factor this to two sets of binomials, one with a plus sign, one with a minus, and then the square root of 49m squared, 7m, 7m. Square root of a squared is a and a.
So it wouldn't matter what you would do if whatever one is first, if it has a minus is the one you put first, I guess? Is what you're trying to say? Whatever one, like the first, like on a negative, so you're talking about 49m squared, so all we would have to do is find the square root of 49 and that'd be 7.
Right.
And then you just put m on one side and then you put that on both
Yeah.
fronts.
And the order does matter in that the positive has to be first minus that part is second, and it stays in that order within each quantity.
So the 7m has to go first?
Yes,
Okay.
it has to go first. Good.
On the homework, would they ever ask us to do like for example, could that be 49m squared minus a to the third? They ever ask that, like not perfect squares?
I don't think they do. I don't think so. Now, could they? Could you see that somewhere as messing it up? Maybe, but
Not today.
Do we
I
have
don't
to
think you have to
work
worry
it
about that
out
right
too, or could we just leave it like that?
now rearrange it. That's all you do is just
So it'd be
that's your answer.
so it'd be 25y squared minus 36a squared, and so it would be 5y and 5y at the beginning. It'd be plus and minus. Plus 6a minus 6a.
Now, you've already put a plus and minus, so you don't have to worry about the sign. You just take the square root. Very simple. It's once you catch it, once you catch on to
We
it.
have to work it out though too.
No. All you're doing is factoring it to two binomials. This is your answer.
They'll always be plus and
Okay.
minus.
Always plus and minus if it's a difference of two perfect squares.
So I was going to ask if they always end up being like something subtracted by something else. So
It has to be that form because if it's,
those are the opposites and everything.
we can't, right, if we do 36a squared minus 25, or sorry, plus 25y squared and tried to factor that, your two middle terms won't factor. Or your two middle terms, when you flow back through, don't cancel each other. So this is not possible. It has to be a difference of two squares. Okay. I'm going to rewrite this. Would you have to? Not necessarily. If you're slick enough to keep things in order and not get turned around and stuff, then you wouldn't necessarily have to rewrite that. I'm doing it because I need to keep it in order that way. It is a difference. I can take the square root of 49a squared evenly. Can I take the square root of 36x to the 6th y to the 4th evenly?
No.
Can I take half of each exponent?
Yeah.
Can I take the square root of the coefficient? Yes, so it is a perfect square then. If I had an odd digit, then if I had an odd exponent, then we would not be able to take the square root of it evenly. But if you have an even exponent, then you can. So this was going to factor to two binomials. And we have 7a plus 7a minus 6x to the third y to the second, 6x to the third y to the second. And that's it.
And so when we have more than one exponent, we just make it so it's divisible.
Half. Yep.
Okay.
You divide the exponent by 2 when
So
you
they
take the square
all
root.
should be being able to have a number of the same. I guess is what you're trying to say.
Sounds good. All right, so this is more on your probability, except that we're going to make it a little bit harder now. The first problem here says, gives you this information and it says something about what is the probability with replacement. What does that mean if it's with replacement? Juliana?
That they put it back.
Okay, when you draw something out, you put it back. Sarah, what's it mean if it's saying without replacement?
And you don't put it back.
Okay, you're not putting them back, and so that's going to change the probability. So let's start with replacement first, because that's the easier. 4 reds, 7 blues, 2 are drawn at random. Okay, what's the probability that the first is red, then the second is blue? Okay, so we're drawing. They want to know what's the probability? Probability of getting red and then blue. Okay, so what's the probability of getting a red the first draw? Ethan.
111.
One. How many reds are there?
411.
4 11ths. And then, what is the probability? The first is red and the second is blue. What's the probability, if we replace that, then put that back in. What's our probability, Sarah, of getting a blue then? 7 11ths. And to get the combination, what's the operation we use, Zach, in probability? Multiplication. So you multiply those two, and that'd be 28 out of 121. That's your probability with replacement. Find the probability of each event and multiply them to find the combined probability. Now, when working without replacement, what's the probability going to be? Right, on our first one, our probability of getting a red is still 4 11ths. Now, we've drawn one out, haven't we? Correct? And what color was it? Red. And we're not putting it back in. So Zach, how many do we have now? 10. So our total on bottom now will be out of 10 because we drew that red one out and we're not putting it back. So I've got that in hand. And then how many blues are left? 7 out of the 10 are blue. Then we multiply those, and that gives you 28 out of, try it again, 111. Nice. And can you reduce it? Yes. 14 55ths.
So we basically go until we get, it's basically like what we were doing earlier, but it's bigger.
Well, not necessarily bigger. It's what we were doing earlier, except that after that first draw, your probability changes because the total we have is different when we're doing without replacement. So A is what we were doing before. And then B is doing it with without replacement. Okay, so there you go. And we'll probably shorten up tomorrow then a little bit for you.
Mr. Clevenger.
Ileana had her hand up first, yes?
Why did you have to put it down?
Because we're wanting to find the combined probability. We know that drawing the red on that first event, there was a 4 out of 11 chance of that. And they want to know what's the probability of getting a red and then a blue. So you're wanting to find the combined, so you have to multiply those. Kyler.
Or we can do it on the